The Cluster C is making an important contribution to shaping the future of flying. Because today, especially the air transport, is growing rapidly. The aim of the cluster's 140 scientists' research is to respond to changing requirements and expectations regarding environmental protection and noise pollution.
Our Cluster of Excellence, Sustainable and Energy-Efficient Aviation, in short C, is doing research for nothing less than a full revolution of the air transport system or of passenger flying. That means we are not researching to develop the next generation of aircrafts, which are maybe looking the same as they do today. We really want to bring down emissions and therefore climate impact of aviation to the absolute minimum for the next generation of flying. From a wider perspective, one could say, well, this is just replacing fossil fuels, kerosene, in aircrafts by different energy storage or energy carriers. But in reality, it's much more to do, because replacing the fuel or the energy carrier means we have to reinvent and rethink the entire aircraft. And it means the aircraft shape will change, the aircraft will look different, and also the way how we will travel in the future will most probably change. And to do that, we have defined 3 different areas within our clusters. The integrated cluster area A, called Assessment of the Air Transport System, is focusing on the entire system. That includes which speed is flown, which altitude is flown, the entire operational research, and also noise, for example. The integrated cluster area B is the vehicle, so flight physics and vehicle. That means design of the aircraft, aerodynamics, structurals, which materials are used. And integrated cluster area C is focusing on energy storage, whether it's batteries or liquid hydrogen, and energy conversion from the energy storage to propulsion.
Current aircraft technologies still rely exclusively on burning fossil fuels. The Cluster C is investigating new, more sustainable and efficient energy supply systems. Key components are electrification, hybridization, and integration of batteries and fuel cells, as well as new combustion engine fuel conversion technologies. The 5 partner institutions of the cluster are also doing basic research into advanced aircraft technologies, especially on drastically reducing aerodynamic drag and structural mass, as well as developing new propulsion solutions. The reduction of drag through systematic laminarization in combination with novel and optimally adapted propulsion systems offers significant energy savings. The goal of the cluster is the design of the transition paths to achieve sustainable aviation solutions characterized by a low carbon and low noise footprint, high operational safety and reliability, and low cost and compatibility. This requires a sound understanding of the air traffic services and of the new aircraft technologies over the entire life cycle, taking into account ecological, economic, and social criteria, and even future scenarios.
What I really like at the Excellence Cluster is that some people focus on components while others work at the overall aircraft level. I am one of those who works on components, and I design engine blades, like the ones behind, that can morph and change their shape. Through morphing, compared to rigid blades that are currently standard, it is possible to increase an aircraft performance.
In the Cluster C, I'm a doctoral researcher working on laminar flow control, which could be a key technology for reducing the emissions of future aircraft. In my project, we're exploiting novel manufacturing techniques such as 3D printing. I like the international and interdisciplinary nature of the cluster and also the possibilities to gain experiences abroad.
Interdisciplinary cooperation between the projects make research a success. This enables the Cluster C to ensure flying for future generations.